Okay, I have managed to continue my program, make it more robust. Well, not robust, I guess I would say. Add more features, add more cool rendering stuff. And as you saw from my, if you did at all, I don't know if you did, but if you did, I showed my previous, I mean my program when I was rendering a simple XY multidimensional function, and it looked like this. It looked pretty shitty. First of all, you can see right from the beginning that there is a problem with this. If you zoom too much in, you can see that this is not really a surface that I'm drawing on the screen. I have a point set. I go to a rectangle of xy, to a plane of xy coordinates, and calculate the z coordinate on every point of the plane, and then put a point over there and simply draw the lines connecting it all together into what you see here. The problem with this is you're not really drawing an actual surface. You're simply drawing lines that are connected, points that are connected together, which can result in, you see, there's no normal depth. You cannot see which side. Just from looking at the picture, you don't know where the front and the back is. It gets kind of confusing, especially with the really complex functions. So yeah, that I tried a few additional polygons. Yeah. Then also an additional, let me call it enshittification of my program was this, because I just didn't know how to do it. I guess I was just stupid. I added a structure polynomial p that would add a term. This would be the coefficient 1, and then this would be the power of x, power of y. So this polynomial in question that I showed, this one, would be 1 times x times y. Okay, if you'd added here 2, it would be, for example, 1 times x squared times y. So this was pretty limiting because you couldn't do any other function. You couldn't do cosine, sine, and all of that shit. You couldn't do time dependence or whatever. So I came up with a better alternative, a lot better alternative, which is simply this computation. I just made a function out of it because obviously a mathematical function is very close, can come very close to an actual function inside of programming, depending on how you look at it. Which is why I call it function and not method, even though we are doing object-oriented programming here, but that's another discussion. Anyhow, yeah, you can see that we have a dependence on time as well, so that the function, you have the possibility of using time as a resource in this computation function, which will be drawn, so you can maybe change it over time or something. That would be cool, you know. And then the x and y. And here I prepared a very cool example, which I will show you in a second. Just bear with me for a little bit. What I added also is indices. So I added triangulation, which I'm going to show you right now. It's basically generating a surface, a very simple surface, and it looks insane. Still, the colors are basically the same. It just generates a random rainbow, but I think it's worth it, and you will see the insane. Just wait for it. Just build it, and actually it's already built. So yeah, this is the thing. We have properties here, and we have a wave function. I prepared a wave function for you to see. We can put this actually pretty close to 0, the amplitude, and you'll see how cool it looks. It's just because it depends on time, it's going to go up and down, up and down, up and down. I genuinely, if I'm being honest, I have no idea how this computational function works. It's sqrt x y times 3 times cosine of sqrt x x y y minus time times some constant that I added, that I randomly threw in to make it faster. But this is how it looks right now. and you can tweak other things. I also added this toggle debug wireframe because I was struggling with the triangulation for so many, I guess a couple days, but it was a lot of time, a lot of energy spent, but you know, worth it, worth it, worth it. So if we click this, you can see the triangles being drawn. And I guess I will show this later as well with a better example, because this is just all wavy and whatever the hell it's doing, it just, yeah, but you can see it's really cool because you can see the triangles. And if we lower the sampling rate too much, it will have too many points, and at some point you will not be able to generate a transient vertex buffer with enough vertices or indices, and by result the program will just crash. So I have to somehow circumvent that, but yeah, I don't know how to do that. It wasn't important for now. The code itself in my program is kind of shit. I need to refactor it. I just want to get this done first. But yeah, you can move around, you can see, you can inspect the function, and I guess it would be cool to have some lighting here as well, although I suck with lightning, but I'll give it a shot sometime. But it's really cool that you have some time dependence now that I added. You can actually tweak the amplitude, which moves it up and down, or you can tweak the sampling rate, which makes it low poly or high poly, high triangular. And if you use a higher sampling rate, actually this is wrong. This sampling is not correctly named. This should be higher sampling rate means it will sample less, and lower means it will sample more precisely. So I should rename this, but yeah, if you add a higher sampling rate, it will just be this mess. And if you use a higher one, you can actually extend the space view by a lot. I mean, and see the function in its glory. Of course, you sacrifice the sampling rate. If I turn it down by just a little bit now, it will basically crash. But yeah, let's actually try a few different functions. You can actually just download this code that I have on my Git instance or GitHub, and you can play with it as well if you want. Maybe add some features, add lightning yourself. I don't know, what do we do? Let's do sine of x. Sine of time times sine of x times cosine of y. Let's see what this will do. Let's see. This will probably like do the wavy thing. It's kinda, yeah. Let me just. Yeah, I know. It will do like a chessboard going up and down. It's cool, but probably not that interesting. Not as much as the first one. Yeah, wait, no, I just put the constant in here, so it will be actually faster, the time itself, not the amplitude. Yeah, now it's cooler. It looks like some boiling water or whatever the hell. Actually, it would be cool to add amplitude over here, so I can tweak it inside of my InGUI and speed up the time or slow it down, as you can see, like so. That's cool. Fuck yeah, it is. Okay. Other things that I want to try, maybe without time dependence, tangent of x divided by sinus of y. I don't know what this will do. I'm scared. Okay, I generated a mess. But I have to do this in order to test my graphics to see if there's any abnormalities that shouldn't be there, because yeah, of course it crashed because I used too slow sampling rate. Because I really hope I just did it correctly, the whole thing. Also, let me just show you. the oh yeah, let me show you. Sinus x times cosine of y times amplitude. I'll just show you the triangulation, how it looks. So it will be easy for you to understand like this, and we lower the sampling rate. You can see how it actually works. It's just a plane. It's just a plane, really. And I wanted to actually the author of BGFX suggested me to use a library for triangulation, but it seemed like, what was its name? CGel? Yeah. Or similar. I guess it's very good. We have very good algorithms here that do amazing stuff. Props to the ones who make it. But I just looked around and found an article on Wikibooks named what was it? OpenGL something. Anyhow, you have a lot of tutorials here if you want to check it out, but this one interested me the most and showed me how to basically do what I needed to do during a surface. I took a look at this, and in a time frame of about like 10 seconds, I was like, how couldn't I have thought up of this before? Because it's such a simple solution. You basically just have a plane for your function is a plane because it only exists in one point only once. So I don't have to go to complex algorithms for polygons because essentially my function is just a, if you remove the z-axis, it's basically just a plane. And what I can do is just draw each of the triangles. Let me lower the sampling rate. I can draw each of the triangles like so. We start at the top or at the bottom, wherever you like, and we draw the first one, bam, 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 then the second one, bam, 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 and we're done with the first element. Then you go to the second, third, fifth, and so on. And you continue and you extend it like this, of course, with the indices. These are the indices. We generate all of those triangles from indices. You tell it, use the first vertex, then the second, then the third, fourth, then the second, fifth, fourth, and then go to the next one, and so on. If you're curious, here's my actual code. Oh, this is a mess. I have to clean it up. So this is code to generate the indices. Use the current one, the next one, and then the one below it. And then also generate, this is for this triangle, also generate the one over here, which is I plus width, which is this vertex. Then the next one plus width, which is this vertex, and then this one up here. You can see I plus 1. And then move to the next one, and so on, and so on, and so on. And until you actually get a lovely mesh. Of course, I had a problem with this, as usual. Even though my algorithm was 100% correct, I forgot a little thing that BGFX has, a little detail of rendering itself, which is I thought that triangle strip was just drawing normal triangles. I don't know why I thought that, but I just thought it. I thought it was the same as drawing multiple triangles in different spaces. No, in reality, what it does in the background is it tries to connect, like the end of the first triangle goes to the end, to the start of the second triangle. Let me show you. This is what happens. The first triangle, or I think the second one, because we start up here, down here actually, in theory. So we draw the second triangle, it ends up here, and then it connects to the start of the second triangle. I mean, to this triangle here. And I just didn't understand why was it doing that. I thought it was generating random triangles out of nothing, out of thin air, because I was looking at the index data. It was all fine. It was enough index data to generate just 1, 2, 3, 4, 5, 6, 7, 8 triangles. No more than that, I promise you. Yet it was still somehow generating those lines. I just thought I was going to go insane, because I've had no idea where this was coming from. But then I started organizing it, trying different combinations of indices, and I realized, oh shit, it's doing what I actually think it's doing. It's trying to connect them all together. And then a little Googling tells me that the owner received a similar question from a guy. Is there a way to just draw triangles without the triangle strip, without trying to connect them together, like link them, whatever? Turns out there is, and it's simply the default behavior of BGFX. You just have to remove the state triangle strip, and it will draw triangles without any linkage between them. Kinda weird. I would prefer that there was an actual constant that would tell you like this, much like a triangle strip, there would be a constant for triangle list or triangle, just triangle. But you know, still okay. It's fine. It's fine. I'm just glad I figured it out, and I'm sharing it now with you. Hopefully, if you have a similar problem. But yeah, this is what I did with BGFX and I've been doing for the last few weeks. If you need the source code, I'll be uploading it soon to my GitHub, so I will leave the link in the description. I need to update, send the new commit and whatever, but because now there's the older version which had the point set instead of the actual mesh rendered. That's it, I believe. But I think I will soon also upload a tutorial on BGFX, because there is really nothing of good tutorials for BGFX out there. You just have the few basic ones. I guess there is this guy or this guy. There is some stuff, but I would say there's too little, because this library deserves more attention. It's, I think, a very solid rendering library. I personally never used. I'm the first one to admit that I never actually did any raw graphics. I don't have any professional knowledge or experience out of it. I did try to do some things like a simulation of gravity in OpenGL, but that's basically where I am at. And now I'm trying to make a game, in BGFX, or just this graphics viewer, because it seems so fun to me that I can't think of anything else to do. So I stumbled upon BGFX, and after I think a month or less of, after a month, about a month or maybe less, of scouting the documentation, looking at examples, looking at the examples provided, at tutorials that I could find, at articles that I could find, I kind of managed to get it working like I just showed you, to get a good sense of what BGFX is doing in the background. I probably still have a lot to learn, but if you're also a BGFX enthusiast, I recommend you join the Discord of them, because it's really good. It's not full of the usual DEI stuff that you usually see. You basically see no politics in here. You just talk about work, you do work, you code, you ask questions, and that's it. And it's fun. So I think that's all. So I'm going to release a few tutorials. I plan on releasing a few tutorials when I will have time again. But definitely will, because I really am passionate about this library currently, and I would like more people to have more resources to get into this. Although it's kind of good, because I see it kind of as a test to see if you are worthy of this library, because it's so good. Maybe only the ones that have enough knowledge will use it. But no, okay, that's just stupid. I mean, I will release a few tutorials because it definitely deserves it. So